Hi everyone! On this new VSPro tutorial, we're going to talk about the terrain system. First, we'll see how to set up the default biome, how to work with multi-terrain, with multi-biomes, and finally, with CTS or Microsplat. We're going to set up VSPro Splatmap generation on a basic Unity terrain, and I will use the default biome I created in the first video. The number of terrain textures should be the total number of terrain layers that you intend to have on a single terrain, including all biomes. Then we have to make sure that our biome is registered into the VSPro system and our terrain is registered into the Terrains tab. Notice here the total area, and in the Settings tab, the sea level, which control the base height used in VSPro rules. We can then go to the terrain system component. In Edit Terrain Textures, you can read textures from the terrain, but here there are none, or apply textures from the package to the terrains. Since rules are not yet defined, it will apply the first layer on the whole terrain, which is the sand. It will create all layers into a dedicated folder. But let's get rid of them and create layers using the palette introduced in Unity version 2008, which allows you to create layers and layers list and easily share them across different terrains. I'm creating here a grass layer, selecting the albedo and adding a normal map. And once this is done, we can go back on the terrain and save layers list as a new palette. Then we can then reuse across our terrains. For the sake of this tutorial, I have already created a palette with sand, grass, rock, and two variations of grass and rock. As you can see here, the whole terrain is covered by sand since it's the first layer. Back to VSPro terrain system, we can read textures from terrain to make sure our previews are up to date, and then use generate splat map. Here it won't do anything since we haven't defined any rules yet. Next up you have enable biome splat map, which we'll see later on, and show heat map, which you can use to visualize how the terrain rules will be applied. Next you can select each layers independently and will be displayed below all the rules associated to this layer. To use the layer in the generation, activate the use with autosplat generation. I'm going to do it for the first 3 layers, and then we can start editing the generation rules. The first graph is the height rule. For the sand, I will define a high density close above the sea level, quickly fading to 0. For the grass, I'll define a high density above the sand and add a steepness rule in order to specify that I don't want any grass on steep slopes. And finally, I'll define the rules for the rock to be the opposite. You can use the Show Heat Map checkbox in order to visualize where the layer will be applied on the terrain. Once you have finished editing your rules, you can hit Generate Biome Splatmaps and then go back to editing in order to achieve the look you're after. Note that we are defining rules for everything above the sea level, meaning that everything under the sea level will be covered by the first layer. Another very important parameter is the total area, and in particular the y-axis with the y-center and y-extent, which define the bounds on which are applied all the height rules. If we check, for example, this sand, and I define a 0% density at 10 meters height, and I then increase my total area y-extents, adjusting the sea level to have the same height as before. After regenerating the biome splat map, the maps are mostly the same, though on a closer look, the height rule has been scaled proportionally to the extents. About hand painting directly on the terrain and hit Generate Biome Splat Maps, it will overwrite the paint. To get around that, select the hand painted layer and use the Lock Textures functionality. If you generate the biome splat map again, it will keep intact this layer's alpha map. Alright, so we are now going to tackle more advanced rules. For instance, I want this second layer of grass to be blended with the first one, especially on those concave areas. Going back to my terrain system, I'm selecting my layer, activating Use with Autosplat generation, and then I'm copying the rules of my grass into my second grass layer so that my 2 layers superpose. And then we can use either Perlin noise to differentiate the two layers, or texture weight to weight one layer more than another. And finally, we can use concave or convex rules. Both have a blend mode, which is either additive or blended. Blended will make sure our layer is only applied where both the steepness and height rules and the concave rule applies. You can refine the concave rule either by changing the sampling distance, either by changing the height differential required to detect a convex or concave area. VSPro will test each point of the terrain one by one. Let's consider this point for the example. VSPro will use the sampling distance in order to sample 8 points around the test point. For each point, it will check the height. So for the sake of the example, we'll consider that the base height is 0 and our testing point is on a local minima on a global slope. Now, if we turn off average samples, the test point height will be tested against the minimum of all the sample points' height. As a result, the point is considered above the sampled height and is therefore not in a concavity. It will be considered convex, and if the convex rule is enabled, it will sample the layer depending on the mean height difference. If the delta height is superior to the mean height difference, the layer will be applied fully. Otherwise, it will be applied inverse proportionally to the mean height difference. So the key points here, without averaging the samples, is that the sampled height is the minimum of all the samples, and therefore any slope will be considered as convex. Using the convexity rule, the more steep is the slope, the more weight will have the layer, and the more mean height difference, the less weight will have the layer. If we turn on average samples, the sample height is the average of all sample heights, and this time our test point is beneath the sample height and is therefore eligible for the concavity rule. As we've seen before, the layer will be weighted inverse proportionally to the mean height difference. Now imagine if the point was slightly above the average, it would be eligible for the convexity rule. And this is why you should use average samples whenever you want to frame local extremas. With that in mind, I'll apply a concave rule with a low mean height difference and a low sampling distance, averaging the samples. Finally, I will use my second rock texture and blend it with the first one using the same height and steepness rules, using both concave and convex rules in order to also generate the layer on the slopes. As you can see, it doesn't look quite right since we are blending two layers at their max weight, so it ends up being 50-50. And that's where the noise kicks in. Using show heat map in order to visualize where the noise will be applied, you can also inverse the noise, and that's pretty much it in order to generate the base Splatmaps. You won't be able to have a very cut out blending using the Unity standard shader. It will always be quite blurry, and in particular, if you want something really realistic with various rocks blending together, you will have to use a height map to control the blending, which is what offers CTS or Microsplat, but we'll see that later on. One thing to note regarding the layers order, the steepness of layer 3 is the inverse of the steepness of layer 4. Now, if we switch the layers in the Unity terrain, it will switch the textures applied on the terrain, keeping the same splat maps. And if we look at the rules, it will also keep the same rules, meaning that the rules previously applied for the rock are now applied for the grass, and vice versa. Alright, we're now going to talk about multi-terrain texturing and in particular workflows. I've created here another terrain and I've purposely offset it from my main terrain. The first workflow is to have as many VSPro systems and VSPro terrain system as you have terrains. I'm duplicating here my VSPro system and terrain. Be careful that you need the terrain system to be on the same game object as the vegetation system, otherwise it won't work on the same scene. Making sure your default biome is properly registered into your second vegetation system pro, and making sure your second terrain only is registered in the terrains tab. We then check the total area and then adjust the sea level accordingly. Instead of using VSP terrain system to assign base layers, I'm going to use the standard Unity palette system and reuse my other terrain palettes and then use generate biome splat maps in order to generate my default biome splats. Now, as you can see, the blending between the terrains is not very nice since we defined the base height independently for the two terrains. So the second workflow is to actually use only one Vegetation System Pro, or more importantly, defining an area that will cover all your terrains at once, making sure you turn off automatic calculation. You can then define a sea level global for all your terrains. It will generate the splat maps for all terrains registered into the VSPro Terrains tab within the total area. This would be the preferred workflow using world map generators with terrain streaming. It's important to note that whatever the workflow you choose, you can still change the textures of your layers per terrain as long as your layers order remain the same and you want to apply the same rules for each layers. If we check the terrain system component, we can see that the previews still corresponds to the first terrain textures. But since the rules are defined by layers index, it will still generate the splat maps for all terrains, and then each terrain will associate the splat maps to the relevant textures. If we look at the biome definition, we can see that even here, the textures previews correspond to the textures on the first terrain. Alright, so we have seen how to define all the rules to generate the default biome. We're now going to investigate how to blend splats with additional biomes. So I'm copying my default biome into a new one that I will name Tropical Biome, making sure we hit Regenerate Vegetation Item IDs since we copied it from an existing biome. Making sure I register the biome into the Biomes tab of my Vegetation system. I can then head on to my Terrain System Pro, select the new biome, and if we hit Generate Biome Splat Map, it won't do anything since we have not defined any biome areas. Let's create one by adding a new game object, add a biome mask area component on it, select the ground layer it will use in order to check for the terrain. We have to select the relevant biome it will define an area for, and we can then place the area on our terrain. If you don't see the point gizmos, you can check into gizmos, enable 3D icons, and in the list make sure vegetation mask area are enabled. At this point, if we generate splat maps, you won't see anything since we still have the same rules as the default biome. So if we then head to the terrain system, check that we select our new tropic biome, we can then modify each rules independently from the default biome. Uncheck use with autosplat generation in order to exclude the layer from being generated for this biome. Let's cover our new biome with sand. As you can see here, the blend is not very nice. One idea would be to add some noise to the layer, but it won't work here since our sand layer is also our first default layer. So basically it will blend the sand with itself. So in this example, we need to add the second layer, which is the dominant default biome layer, to our generation rules, adding some texture weight to our sand in order to have more sand than grass. We can see that the blend is still crappy. We can add some noise in order to add some randomness to the splat map generation, however, using the Unity standard shader without height-based shading. Since we can't control the sharpness of the noise, the result will always be blurry and therefore quite crappy if you try to blend such different textures as sand and grass. You can also control the area blending on your biome mask area. You can change the texture blend settings curve, control the blend distance, and add some noise in order to blend the biome area a little bit more naturally. Now let's add some new layers specifically for this new biome, adding the layer directly to the Unity standard terrain. The layer will be picked automatically by the terrain system, and we can activate use with autosplat generation for our new biome. Since the option is off by default, it won't be used by the default biome unless you turn it on. After fiddling with the rules, I finally obtained this blending, which looks much more natural than the sand and grass blending. Now keep in mind that the Splatmap rules are stored per biomes, which means that the first biome will not be impacted by the rules of the second biome, but which also means that if you modify your Splats rules using one terrain, it will impact all other terrains as well, which can be used to our advantage since we only need to keep the same number of layers in the same order, but not the underlying textures used by the terrains. As you can see here, the new layer is not applied to the terrain, and this is because we have not yet added the new layer to this terrain. We can either create a new layer or reuse an existing palette or even reuse an existing layer. In this case, I'll select a layer I prepared previously that uses a texture different from the first terrain. And for this last tip, I had forgotten to record it. So I recorded after I added Microsplat. So don't mind here the change in the shader. I'm still using my tropics biome and I've added a third biome. And what I wanted to show you is whenever you press generate splat map, it will generate the splat maps for all biomes, even if you clicked on one specific biome button. So it's recommended that you keep all your biome mask areas at all time in order to be able to regenerate the whole splat map when you want to add a new biome. Alright, we are now going to talk about VSPro with CTS. It's not a CTS tutorial, so we'll just look at some settings that you're probably looking after when using CTS with splat map generation. First off, don't use apply textures to terrain on the VSPro terrain component, since the layers are overwritten and linked to a texture array handled internally by CTS. The two features you'll probably want are the trilinear rendering and the height map blending. Use the trilinear rendering on textures that are applied on steep slopes in order to avoid stretching them. Try to avoid using them when you don't need them, since they are performance intensive. Then to use height blending, you need to change the shader type to at least advanced and then provide height maps for each layer. You can then control for each layer how the height map will be used in order to blend the layers together. So keep in mind all the settings are relative to other layers as well. I personally prefer when the rocks are quite sharply blended with other textures, and layers like sand can be blended more softly in order to simulate some sand being on top of other layers. And finally, we'll talk about Microsplat integration with VSPro. Similarly to CTS, you can use triplanar rendering if you have the triplanar module, and height map blending. You can control how you blend textures globally or per textures. One thing to know though, you might encounter blurry areas caused by too high differences in UV scale of blending textures. From my own experimentation, I found that ×4 should be the limit. You have plenty of ways to break the tiling in Microsplat, for example using the anti-tiling module or the texture clusters module. Another feature I find very nice to blend textures are the outlines. As you can see here, I put a brownish outline to my grass in order to simulate dirt, and I basically got rid of my second layer of dark grass. The two other features I wanted to talk about are specific to VSPro integration. Those are grass maps and shadow maps. The grass map allows you to simulate grass at high distance by adding a tint to the terrain where there should normally be grass. You can change the tint in the Microsplat material. The grass position should be imputed directly into the Microsplat terrain component. This map can be generated using VSPro. Using the Vegetation Color Mask Creator component that you add onto your VSPro system game object, select the area or select the terrain and snap to terrain, select the resolution you want, a layer that is empty, a slight overscale, and then select include grass. It will generate Microsplat input texture with a grass as white in the alpha channel. The second feature is shadow maps. Shadow maps are used to fake shadows after the shadow rendering distance. Shadows are faked by darkening the terrain and are therefore much less performance intensive than real shadows. Microsplat uses the 3 positions in order to generate the shadows. The 3 positions have to be imputed through a texture map that we can register directly on the Microsplat terrain component. The texture can be generated using VSPro Shadow Mask Creator. Now, in the latest version, 1.3.4, the Shadow Mask Creator is not generating the right texture. The final output is way too red, creating way too much shadows. So I'll show you how to generate a shadow map that is good enough using Vegetation Color Mask Creator. Similarly to the grass mask, you'll have to select a bunch of settings and then make sure you include trees and eventually large objects or any vegetation category you want to generate shadows for. The trees will be generated as white in the alpha channel. We actually want it to be red, which is very easy to make using your favorite image editor. Here I'm using Photoshop. Create a black background layer, then a red layer on top of it, and use the generated texture as a mask for the red layer. Input the generated texture to your Microsplat terrain component. Make sure the light defining your sun is registered in the VSPro system component in the render tab. You can then play with the shadow settings directly in the Microsplat material. As you can see, if you change the sun direction, it will also adjust the shadows angles. And this is it for this tutorial. If you like, please like it and subscribe for more videos or more news on Machine Tail.